Shall I? Once you tell, I'll start. Good morning, everyone. Welcome, everyone, for the third day of national level webinar series on BIS Codes in Civil Engineering, organized by Department of Civil Engineering in proudly association with the Association of Consulting Civil Engineers Mysore Center. Thank you all for joining us for third day national level webinar. Myself, Kanmani SS, serving as Assistant Professor in the Department of Civil Engineering. I will be MC for today's webinar on BIS Codes in Geotechnical Engineering by our beloved HOD, Dr. S.K. Prasad. Before we start, let me announce the two winners of yesterday's e-quiz on BIS Codes for plain and reinforced concrete structure, that is IS 4562,000. Second place goes to Mr. Roshan Ramdas Gadpal, faculty member from Government Polytechnic, Amravati, Maharashtra. I repeat, second place goes to Mr. Roshan Ramdas Gadpal, faculty member from Government Polytechnic, Amravati, Maharashtra. And the first place goes to Akash Kumar Verma, practicing engineer from CSIR, CRRI, Ghaziabad, New Delhi. I repeat, Akash Kumar Verma, practicing engineer from CSIR, CRRI, Ghaziabad, New Delhi. Congratulations to both the winners. Now, to begin with, I request our coordinator, Dr. P.K. Umecha, sir, to welcome the participant and introduce the speaker.
Thank you, madam. Dear students, research scholars, faculty members, practicing engineers, very good morning to everyone. It gives me immense pleasure to perform three duties: to speak about Vidyavardhaka College of Engineering and the Department of Civil Engineering VBCA Mysore, to welcome everybody to the webinar on BIS Code for Geotechnical Engineering, being presented by Dr. S.K. Prasad, HOD, Department of Civil Engineering, organized by VBCE in collaboration with the Association of Consulting Civil Engineers Mysore Center, as a 6-day webinar cum e-quiz on BIS Codes in Civil Engineering, which is started on 20th July, that is Monday. And also to introduce the Dr. S.K. Prasad, HOD, Department of Civil Engineering. Firstly, I am extremely happy to speak about our institution, Vidyavardhaka College of Engineering, which is situated in the heart of city of Mysore. It is one of the most prestigious and most popular engineering colleges in the state of Karnataka. VBCE has accredited by NBA and NAC with A grade. It has been granted autonomy from VTU from this academic year. It has 6 branches of engineering, namely computer science, information science, electronics communication, electrical engineering, mechanical engineering, and civil engineering, with an MBA program. We are going to start one new program that's called BE in Machine Engineering and Artificial Intelligence from this year. I'm very happy to inform that VBC has placed 20th place in the country during this year by IIRF, published by Education Post. Next, the Department of Civil Engineering has a 60 intake in BE program. It has recognized as a research center by VTU. It has a very good, dynamic, and dedicated faculty members from all specialization of civil engineering with an average age of 35 years. It has an excellent laboratory infrastructure, very good teaching learning ambience with a focus on practicing training, very good faculty-student ratio, concentration on faculty-driven research, departmental library, research laboratory, spacious seminar hall, independent computer lab, and many other facilities. I am sure any student of VBCE Civil Engineering is lucky to be on this campus. Secondly, I wish to first welcome our today's speaker, Dr. S.K. Prasad, HOD, Department of Civil Engineering at VBCA Mysore. He is going to deliver on a lecture on BIS for Geotechnical Engineering. I welcome all the participants, and I am happy to state that there are more than 1,400 registrations comprising from UG students, PG students, academicians, researchers, and working professionals from Karnataka, and all over India. I welcome all members of ACCE Mysore, especially Chairman Engineer S. Prakash and Honorary Secretary Engineer MS Ram Prasad for and all the members of MC. And also we would like to thank Engineer MS Prasad, Honorary Secretary ACCE Mysore Center for gesture for sponsoring this event. And also welcome all my colleagues from VBCA, both from teaching and non-teaching community. Welcome one and all. Thirdly, I'd like to introduce our today's speaker, Dr. S.K. Prasad, HOD Department of Civil Engineering, VBCA Mysore. Dr. S.K. Prasad is a professor of Civil Engineering at Vidyavardhaka College of Engineering, Mysore. Recently, he is superannuated as a professor of Civil Engineering at Sri Jayachamarajendra College of Engineering, Mysore. He has over 35 years of teaching and research experience. He obtained his bachelor degree in civil engineering from the University of Mysore, securing first rank in 1982. And he got a master degree Institute of Technology, Kanpur in 1985. He got his doctorate degree from University of Tokyo in Japan during 1996. He is a visiting assistant professor at Asian Tech Institute of Technology, Thailand for January 2006 term. He has published more than 160 technical papers in national and international journals and conferences. He guided more than 70 master dissertations and also guided 3 doctoral students. He has completed several sponsored research projects from JSS MFE, AACTE, and also from DST. His area of interest are earthquake geotechnical engineering and in performance-based design. Thank you very much, sir. I welcome Professor S.K. Prasad to give today's talk, that is the BS for Geotechnical Engineering. Thank you, Ananda.
Thank you, Dr. Umesh. Very good morning, everybody. First of all, I wish to thank my young brigades in the Department of Civil Engineering here at Vidyavardhaka College. Yeah.
Sorry to disturb you, sir. Just a little housekeeping before we get started, I should say.
Okay, please.
For all the participants, it's okay, sir. If you have any questions during presentation, please type them into the chat box. We will bring them up at the end of the session. If the time is exceeding, we will mail the answers to your email ID. The link for feedback and quiz will be posted in the chat box at the end of webinar. The quiz link will be active till 3 o'clock. Merit certificate will be issued for the top 20 of the participants. Those who score maximum marks will get attractive prizes. In case of tie, we will consider the time stamping recorded in the Google form. Prizes will be issued once after the webinar series gets completed. Again, to repeat, today's winners, yesterday's e-quiz winners are first place CRRI, Ghaziabad, New Delhi. And second place goes to Roshan Ramdas Gadwal, faculty member, Government Polytechnic, Amravati, Maharashtra. So now, without a further ado, we will turn the time over to Dr. S.K. Prasad, our presenter today, HOD Department of Civil Engineering, Vidyavardhaka College, Mysuru. Over to you, sir. Thank you.
Thank you, Professor Kanmani. In fact, we have now become very different during this pandemic. We're all at different places. I just forgot that, you were doing this MC today. Thank you. Very good morning, everybody. So as I was mentioning, I'm very happy that, in VBCE Civil Engineering, I have young brigade led by Dr. Umesh, and things are going exceptionally well. And I'm really proud and happy that, there have been 1,400 plus participants in the, webinar, and maybe more than 500, participation in the e-quiz from all over the country, which makes us really proud and happy about it. And as mention, first of all, my thanks to Dr. Umesh for, nicely, presenting me. And then now I'll be talking about geotechnical engineering, the IS codes related to geotechnical engineering. So in this webinar, I restrict to whatever IS code says. Opportunities where we say that in geotechnical engineering, we desire a lot of improvements in IS code, and we still do continue with the older versions only. Still, I'll restrict my talk to only what is there in IS. Whenever I start my lecture in geotechnical engineering, I pose this question to everybody as to name popular construction materials. And even with our students, when I ask, everybody says cement, concrete, brick, mortar, everything. But very few people say that, soil is also a construction material. Honestly speaking, if you look at, infield, you take an embankment, you take an earthen dam, you take a rockfill dam, entire material is made out of soil, and hence soil also is used for several other purposes like brick making, tile making. So soil is perhaps the most common, most used, least expensive construction material. In addition, you build all your structures on the soil, on the ground. Therefore, soil is very important to civil engineers. Peculiarly, soil is not easy to handle. It has, different properties at different places. And at the same place also, its properties, are very different at different times under different situations. So I always say that it is a very complex construction material and hence poses a lot of uncertainties. In fact, the presence of water in soil makes it very, very complicated. So considering the complexities, there needs to be some standards because, because of the variations, things can go wrong if we are not, considering things properly. And hence, Indian standards will have to play an important role. Unfortunately, I feel in geotechnical engineering, it is not followed to a full extent, though we have many, many codes. I will not be listing all the codes in geotechnical engineering, and my focus in this presentation is on only 3 codes. To start with, foundation is the most important geotechnical structure. Whatever load the structure carries, whatever forces, moments the structure carries, through the foundation, will have to transfer the stresses to the soil. So stresses will be stressed more than what they were before the structure is built. So question is whether the soil is capable of taking that stress. So we need to have a knowledge about the capacity of the soil. That's why, bearing capacity of soil plays an important role, and hence, safe bearing capacity of soil is one of the most important parameters in the design of foundations. Secondly, whenever you build any structure on soil, as you saw in the first slide, soil is a conglomeration of solid particles with a lot of white space in between them. That white space is filled with air or water or both of them. When you apply an additional load, there is every possibility that the soil particles may settle more, and hence causing the settlement of the structure. We can't allow settlement beyond limits. I always talk about these 2 classical cases. Mexico City, where you can expect a settlement of the order of 1 meter in 1 year because of the fat clay, soft clay. When you apply any load, there is a possibility of consolidation settlement causing huge settlement. And then Leaning Tower of Pisa, it is famous for its differential settlement. So settlement should be kept under control. It should not exceed the limits. So that's the other important objective we should know. Then, as I said earlier, soil at different places is of different varieties, different qualities, and so on. So at the site, we should ensure that soil has certain characteristics, certain safe bearing capacity, its settlements are within whatever limits possible, and so on, for which tests are necessary. The tests can be conducted in the field. Tests also can be conducted in the laboratory, and sometimes, depending on the importance of the structure, we will have the test conducted both in field and laboratory. In field test, SPT, standard penetration test, plays a very important role. Keeping all these in mind, I have decided today that I'll be talking about 3 codes. The first one is IS 6403, which talks about how the SBC of soil has to be computed. Please note that SBC is not a unique value. Sometimes vaguely we ask, what is the SBC of soil at this site? It is dependent on many, many factors, and that's what we are going to discuss as per IS 6403. The second one is IS 1904, which talks about what factors to consider to determine the depth of foundation. Please note that depth of foundation is the depth from the ground surface to the bottom of the foundation. Only when you know the depth of foundation, you will be in a position to decide the type of foundation. And in addition, you also have some details about settlement. What is the permissible settlement as per Indian standards? And lastly, we spend a little time on standard penetration test and some of the corrections suggested in IS 2131 with regard to the standard penetration number. Well, friends, I'm going to start on IS 6403, which is a Indian standard code for the determination of bearing capacity of soil. As I mentioned to you earlier, bearing capacity of soil depends on many factors. And this code covers factors such as mode of failure, effect of presence of groundwater table, effect of shape of the footing, depth of the footing, inclination of the load, eccentricity in load. It covers different types of soils, the 2 extremes, cohesive soil and cohesionless soils, and the determination of bearing capacity from 2 field tests, standard penetration test, as well as standard static cone penetration test. Well, bearing capacity, as I mentioned earlier, the structures do carry load. And all these loads, forces, moments which the structures carry will finally have to be transferred to the soil below. There is a foundation in between which actually transfers the structural load to the foundation soil. And this soil should carry some strength, should have some capacity. If its capacity is low and we design a structure which carries much bigger stress, automatically we see failure. One of the most classical failures I have presented here, this is transcoma grain elevator. Way back, more than 100 years back, I think 1913, in Canada, this failed. The failure was purely due to bearing capacity failure. People had assessed the bearing capacity. At that time, there was not much of geotechnical engineering known. Professor Tezzaghi had not put forth his theory yet. And then, it was loaded, the grains, so during the harvest, they had good supply of grains, they started loading it. And once the the stress increased beyond the capacity, it experienced general shear failure. Those of you who are interested can always have a look at it. Lot of articles are there on that. What is important is to find out how much is the capacity of the soil here. The maximum capacity, we call it as ultimate bearing capacity. So in IS 6403, these definitions are there. As I said, ultimate bearing capacity is the maximum capacity the soil below the foundation has before it experiences failure. We also sometimes use net ultimate bearing capacity, and in IS code, it is symbolized as QD. So if I consider this as the foundation, it is the foundation level at which I would like to know the capacity. At this place, before the structure is built, soil has some load, some overburden pressure. Net ultimate bearing capacity is that extra pressure beyond the initial pressure which the soil can take before it fails. Then you have safe bearing capacity, which is the safe load, safe extra load in particular, the soil can take in addition to its own initial overburden pressure. Therefore, we always put factor of safety. Suitably, factor of safety of 3 is taken. So SBC is very much used in the design of geotechnical structures. Also, allowable bearing capacity, as mentioned in IS code, sometimes we say allowable bearing pressure, which is more superior to safe bearing capacity. Safe bearing capacity talks only about shear failure, but there is also settlement. You know what is the permissible settlement. So what is the stress you can allow to reach that permissible settlement? You can find out. And you can also find out safe bearing capacity. The lower of the two is taken as allowable bearing pressure. So I always say that allowable bearing capacity or allowable bearing pressure is much more superior to safe bearing capacity, because you consider not just the shear failure, but also the settlement into account. Going directly into the bearing capacity equation, all of us know that bearing capacity was initially determined based on the theory, which is based on moment equilibrium, limit equilibrium theory, and way back in 1920s, Prandtl, and then 1943, Terzaghi, and several other researchers later on in the 80s, Meyerhoff, Bala, several people, gave these bearing capacity theories. This is a generalized bearing capacity theory as given in Indian Standard Code. QD here stands for net ultimate bearing capacity, which I explained earlier. And then, it has 3 terms. The first term is basically the cohesion component. The second term is the surcharge component. And then the third term, which is the weight of the soil at the base of the foundation. So the terminologies here are mentioned. I say that this is generalized because initially when Terzaghi and others gave the equation, they had not considered several other factors like shape factor, depth factor, and so on. But here, all these are considered. So here, C stands for unit cohesion of soil. Then you have these terminologies, NC here, NQ here in the second term, N gamma. These are called bearing capacity factors. These are dependent on angle of internal friction of the soil. So you have tables, you have charts, you have equations. Using any one of them, you can find NC, NQ, and gamma. Then you have, yes, shape factor for cohesion, shape factor for surcharge, shape factor for gamma. D stands for depth factor. You might try to find the bearing capacity at the surface or at some depth below or at great depth below. Naturally, when you are considering greater depths, the confinement comes into picture because soil is always granular, and hence you need to apply this correction for depth factor. So DC, DQ, D gamma represent these corrections for depth factors, and then I stands for the load inclination of the load. So you have the regular equation for the load being vertical, but in any case, there also is a possibility that you have some horizontal forces on the structure, and hence the resultant force, may be inclined to some angle with respect to vertical. So in that situation, you consider the effects of load inclination factor. So IC, IQ, I gamma represent the load inclination factors. And then, finally, you have B, the width of the foundation, and W dash, it is the correction you apply for the groundwater table. And I just forgot to mention Q here. Q is the surcharge pressure. So surcharge pressure at the base of the foundation. If you have gamma as the unit weight, D is the depth of the foundation, Q, surcharge pressure, will be gamma D. In case there is an additional surcharge of say Q naught, then Q will be equal to gamma D plus Q naught. And which gamma to take? You generally, you'll have to consider the surcharge. Therefore, you consider the bulk density of the soil. And this equation is applicable to strip footing. So in order to find out QD represents the net ultimate bearing capacity of soil. Then QD divided by factor of safety plus the overburden pressure, initial overburden pressure, that is Q, will give you the safe bearing capacity of soil. So in order to find safe bearing capacity of soil, you require QD. So this is for strip footing. And you need to know all these parameters to find out QD. You find out C, the cohesion of soil, phi, the friction, angle of internal friction, gamma, unit weight of soil from the field tests, or maybe from the samples collected in the laboratory and tests you do in the laboratory. And so beforehand, you'll be knowing the values of C, gamma, and then phi. And other things can be obtained from the formulae, which I'll be showing you. NC, NQ, and gamma, which are the bearing capacity factors, they are obtained from this table as per, IS 6403. But then, equation is also available and graph is also available. And you can notice that with increase in phi, all these parameters increase. Therefore, bigger the strength of soil, bigger will be the values of NC, NQ, and gamma. Automatically, bigger will be the bearing capacity of soil. And here you are given NC, NQ, and gamma at an interval of 5 degrees. So if the value at the site is anywhere in between, you are supposed to linearly interpolate. So using this data, you can find out, depending on the value of phi, NC, NQ, and gamma at the site. Then the shape factor is obtained from these formulae, which are again in this IS code. Normally you have a continuous strip footing, or you may have a rectangular, square, or circular footing. So you are going to apply these shape factors to the 3 terms of bearing capacity equation as shown here. So if it is strip footing, shape factor is 1, square footing 1.3, circular footing 1.3 for SC. And if it is rectangle, then you need to know the dimensions of the footing. If it is a footing of size 2 meter by 3 meter, then SC is equal to 1 plus 0.2 into 2 by 3. Likewise, you find out SQ and S gamma. Here B happens to be the width of the footing and L happens to be the length of the footing. Then depth factor. So depth factor is obtained from the formula which are given here. So please note that DC is equal to 1 plus this value. And DQ and D gamma will be equal to 1 if the value of phi is less than 10 degrees. If it is more than 10 degrees, less than or equal to 10 degrees you can take. And if it is more, then DQ and D gamma are given by this formula. What is there here? DF happens to be the depth of the foundation. As I told earlier, it is the depth from the ground level to the bottom of the foundation. And B is the width of foundation. N phi is given by this formula tan square 45 plus phi by 2. So using these values, you can find DC, DQ and D gamma. And please note that DQ and D gamma are the same, but their values will have to be obtained based on the value of phi. If phi is less than or equal to 10 degrees, you use this formula. Simply DQ and D gamma are 1. If phi is greater, then their effect in depth and hence in bearing capacity will be more. And hence, you have an equation like this. The next one is inclination factor, load inclination factor. Load is supposed to be vertical, but then, if you have a horizontal component, then the resultant force will be inclined, by some angle alpha with respect to vertical. So IC, IQ, I gamma are given by this formula. Please note IC and IQ are the same, equal to 1 minus alpha by 90 to the power 2. If alpha is 0, IQ and IC are 1. That is for load which is vertical. Just assume that load is inclined at 10 degrees. That means, there is some horizontal component also. It is 10 degrees to vertical, not to horizontal. Then IC and IQ will be equal to 1 minus of 10 by 90. This quantity rise to the power 2. So basically, the effect of load being inclined is to reduce the bearing capacity. So IQ and IC will be reduced. Similarly, I gamma is also given by this equation, where alpha is that angle with which the load is inclined to vertical and phi is the angle of internal friction. So we have covered now effect of shape, effect of depth, and then effect of load inclination. Then you have water table. The groundwater table will be fluctuating. And at some places, groundwater table may be near the surface. And at some places, groundwater table may be at great depth. And at some places, groundwater table may be somewhere in between. What Indian Standard Code says is that, you have to apply the effect of the presence of groundwater table in the third term. And this term has, the coefficient W dash. And the value of W dash is said to range from 0.5 minimum to 1. And the details are given here. I'm going to explain these details. Case 1, when value of W dash is 1. Case 2 or B, when value of W dash is 0.5. And case C, when value of W dash is anywhere in between 0.5 and 1. So let me just tell you that you need to consider these variations to be linearly interpolatable. So you need to linearly interpolate between 0.5 and 1. Basically, the effect of the presence of groundwater table is varied from the base of the foundation till a depth below the base of the foundation, which is equal to the width of foundation. This is the influence zone for W dash. As I said earlier, W dash varies from 0.5 to 1. It is 0.5 when the groundwater table is either at the base of the foundation or above the base of the foundation. And then, it is equal to 1 when the groundwater table is beyond this level. What is this level? From the base of the foundation, you go for a distance equal to width of the foundation. If it is anywhere beyond this, you say it is 1. That means there is no interference of groundwater table. And then when the groundwater table is in between the base of the foundation or a depth at which, it is from base, it is at B, width of foundation, you have to linearly interpolate. You can use a simple formula like this. What does ZW indicate? ZW indicates the depth of the groundwater table from the base of foundation. So if you are investigating at a site, you find out when the groundwater table will be at its highest level. You'll have to either find out from the local people, or perhaps you can search out for a shallow well and identify. So this requires some amount of experience. Therefore, you should find out where you expect the groundwater table to be. And if it is at great depth, you don't have to worry. But during rainy season, if it is likely to rise to closer to the foundation, you need to take the effect of this. So as I said, case A, wherein the groundwater table is at great depth. What do I mean by great depth? From this level, it is at much lower level. What is this level? Base of the foundation, and this level is at a distance B from the base of the foundation, where B is the width of foundation. So in this case, there is no interference of groundwater table, and hence W dash is equal to 1. So I just mentioned RW2, it is actually influence of W dash. Then case B is when the groundwater table is at the base of the foundation or above, like this. In all these cases, the value of W dash has to be 0.5. You'll have to take W dash equal to 0.5. That means you can see the third term in bearing capacity equation will reduce to half. Then this case in which groundwater table is from the base of the foundation till a depth equal to width of foundation from the base. So in that case, you measure ZW and then substitute here ZW, put B and use this equation. If ZW is 0, W dash is equal to 0.5. If ZW is B, W dash is equal to 1. And anywhere in between, it is a linear interpolation. So it ranges from 0.5 to 1 here. Next, I take you on to mode of failure. Depending on the kind of soil, soil properties, whether it is stiff, dense, or soft, loose, the failure is going to be different. So basically, 3 modes of failures have been identified. General shear failure in dense soil, stiff clays or rocks, and local or punching shear failure in very loose soil, loose cohesionless soils, or soft clay. And local shear failure actually is in between the 2 extremes. So in general shear failure, there will be hardly any displacement. You keep on applying the load. At one load, it will have a catastrophic failure. No warning. And when it fails, the footing simply rotates. That is exactly what happened in the classical example which I showed. Transcoma grain elevator in Canada. And once the footing rotates, you can see bulging on one side. If you try to see the load settlement curve, you can see that, as the load increases, the settlement increases, but at, marginal increase. And at one point, you can see the peak. And after that, failure will be continuous. On the other hand, in punching shear failure, you will hardly see any failure. The soil is very loose and the footing, keeps on going down and down, experiences large settlement. There is no peak at all found in load settlement curve. And, settlement continues and continues as the time proceeds. So that is punching shear failure. And you will never see any bulging on the sides of the, foundation. And the settlement will be enormous compared to the first case. Local shear failure is in between the two. So I have actually put the distinctions between general and punching shear failure here. Local shear failure comes in between. So as I said earlier, in stiff soils having phi equal to 36 degrees and above, SPT-N value very high, relative density very high, and cohesive soil having very good cohesion, that is stiff soil, you see general shear failure. On the other hand, punching shear failure is found in soils with phi equal to 28 degrees, SPT-N value very low, 0 to 5, relative density very low, 20%, and also cohesion, undrained cohesion, very low value of 50 kilopascal. We can actually go through all these distinctions, and what the IS code says is that if the soil has phi equal to or greater than 36 degrees, it experiences general shear failure. And if the soil has phi equal to or less than 28 degrees, it experiences local or punching shear failure. Anywhere in between 28 and 36 degrees, it is not known. It could be any of them. So it's called mixed shear zone, okay, or an intermediate zone and like that. So that place, we are not sure whether it is local or punching shear failure. If it is general shear failure, no correction is required in that equation. Use it as it is. On the other hand, if it is local shear failure, you need to reduce the shear parameters. Reduce the shear parameters to 2/3. That means, instead of C, you use C dash. C dash is equal to 0.67 times C. Instead of phi, you use phi dash. So tan phi dash is equal to 0.67 times tan phi. So phi equal to 30 degrees, 28 degrees will reduce to maybe value corresponding to this 90 degrees or so. And hence, you need to take the reduced bearing capacity factors, not the actual phi. You need to consider lowered phi, and accordingly, you will be finding the lowered bearing capacity factors, NC prime, NQ prime, and N gamma prime. Use them in the equation provided. Therefore, bearing capacity is going to be drastically reduced. So this is the correction you will have to remember. And if phi is anywhere in between 28 and 36 degrees, people don't mention much. They simply say that you can do linear interpolation. And that is where you need to be do a more laborious job. So when I say linear interpolation, perhaps you consider phi to be general shear failure kind, and hence faint bearing capacity. Consider it to be local shear failure situation, find the bearing capacity, and in between them linearly interpolate between phi equal to 28 and 36 degrees. The other factor considered is load being eccentric. So eccentricity of load comes into picture in this part of the equation, the third term where B is there. Instead of B, you use effective B. But for all calculations, the length also may be effective length. You need to consider the eccentricity in the other direction also. And hence, the area which you consider is not the actual area of the footing, but the effective area of the footing. Therefore, the effect of eccentricity of loading is to drastically reduce the bearing capacity of soil. So, just a little briefing on eccentricity of loading. So, the equations which I showed earlier are derived considering that the footing is concentric. That means, concentrically loaded. That means, the CG of the load coincides with the centroid of the area of the foundation. And hence, the pressure at the base is uniform. On the other hand, there is every possibility that the resultant might shift from the centroidal position. And if it is shifting like this, okay, automatically the footing is eccentrically loaded. The pressure is more on this side and less on the other side. And that's what causes differential settlement also. So you need to be very careful when you have the eccentricity. So the Indian standard says that eccentricity should be taken into account. Therefore, the area of footing considered will be smaller than the actual area of the footing as shown in the details here. What is that you do? And why will you have eccentricity? Either when the column itself is, kept eccentrically, or when the column carries a moment also in addition to axial load. So in this case, I'm considering a column load along with the moment, and hence, its equivalent, when you apply the mechanics, equivalent position will be eccentrically loaded, something like this. So this is the amount of eccentricity E. So when you have the eccentricity E like this, the CG, which was actually supposed to be here without the moment, without the eccentricity, gets shifted towards here. So now this is the CG point. So what the IS code says is that instead of taking the full width, you take this much width where this is the center line of this new width. So new width is B dash. So B dash is simply equal to B minus 2 times E. B dash is simply equal to B minus 2 times E. That is exactly what is given here. L dash is equal to L minus 2 times E in that length direction. B dash is equal to B minus 2 times E in the width direction. So this is how you will take. So B dash you will take like this. So instead of considering the varying load, you consider that over this area the load is uniform. So this is that E in the direction of the width. So you can call it as EB also. So this is 2 times EB. Therefore, B dash is equal to B minus 2 times EB. And in a situation where eccentricity is not just in one direction, not just in X direction, also in Y direction, like here, you can see that this is the CG position. It has shifted to here in the width direction. It has shifted to here in the length direction. Therefore, the new position of the centroid as well as the CG of the loads is here, not here, because of the two eccentricities. Therefore, I need to consider only this much area. This is L dash and this is B dash. This is B dash. So, B dash is equal to B minus 2 times EB. Instead of EX, you can call EB or EX also. And L dash is equal to L minus 2 times EY. Okay, friends. I quickly move on to the other things. If you have two extreme cases, cohesionless soil is one thing, or cohesive soil. Cohesionless soil will have C equal to 0. All granular soils come under this. Based on relative density, you can say whether the failure is of general shear failure, local shear failure, or anywhere in between. As I said, when the density of the ground is very high, it is general shear failure. When it's very low, it is local or punching shear failure. In between, you have to interpolate. You can also mention with respect to void ratio. Then, with respect to SPTN value, here you see, you can always conduct SPT test and corrected N value you can put from the top till whatever depth you want. And the depth we normally consider is, about 1.5 to 2 times B below the base of the foundation. And you normally will have the vertical spacing of SPTN value about 0.5 to 1 meter, usually 0.75 meter. When you have the data like this, you take the average value below the base of the foundation. That's what IS says. While doing so, sometimes in between, you might get one very huge N value that may be due to mistake. There may be a small pebble, and hence, that may be offering the resistance, so you don't know. So in case the value of N, that one exceptional case, is much, much more than 1.5 times the average, you discard that and take the average of the rest of the things. So I've just shown here, if N is, let us say, 10, 12, 14, 16, 18, take the average. If you have N something like this, 10, 12, some intermediate value, very high, 40, 16, 18, remove that and take the average of the rest of the things. That's what you do. And once you take SPTN value, IS code says that it can be correlated with the friction angle of the soil. So you can use this graph, and hence, if SPTN value is, let us say, 30, then corresponding friction angle phi is equal to 36 degrees. So from SPT, you find out phi. Use that phi in the calculation of bearing capacity equation. Or you also can use ACCE results. The point resistance QC you get from ACCE test. Let us say if this is the table which is given in this IS code. If B is equal to 2 meters, depth of the foundation is 1 meter. Then for DF by B equal to 0.5 as seen here, if the width is 200 200 centimeters or 2 meters, then corresponding to this, the ratio of QD by QC is this value, say 0.2. You know QC, you would have done SCPT test, static cone penetration test. So knowing QC, you will be able to find out QD. So that's the net ultimate bearing capacity of soil. So you can use SCPT results also. This is for purely cohesive soil, phi equal to 0 soil, clayey soil. The equation QD will have only the first term, second and third terms will vanish. And NC can be taken as 5.14. You can find out C from unconfined compression test, or you can use SCPT results also to find the undrained cohesion approximate value ranging from QC by 18 to QC by 15 when QC is less than 20 kg per centimeter square. And then you have also for the other situation. You may have 2-layered soil, both cohesive. So first layer, top layer may have cohesion equal to C1. Bottom layer may have cohesion equal to C2. Then you use the same equation as before, but the cohesion you have to consider is C1. And that you obtain from this table, in this chart, this figure. So you will know C1, you will know C2. So C1 and C2, the values are known. And you also will know the thickness of the top layer D. Depending on the thickness of the top layer, the values of C1 and C2 change. And the values of C1 and C2, the value of NC will change. So NC depends upon not only C1 and C2, but also thickness of this. If this thickness is very small, mostly the affecting soil will be one with C2. And there are chances that C1 is greater than C2 also. So you always will have to take this into account. That's why, if required, you can take 2-layered soil. So I'm going a little slow, therefore I'll be slightly more quicker from now onwards. I take you on to the next code, IS 1904, which basically talks about soil exploration, of course, it is given in greater detail in IS 1892. What are the factors influencing depth of foundation? And then it also talks about the permissible value of settlement. Site investigation is very, very essential. I always keep saying that, it is extremely important. Unfortunately, in India, we don't do a very good job. So here, these people were doing site exploration, all geotechnical engineers. So they were digging, And unfortunately for them, they found out this, a Python. Fortunately for them, they found it at Python. So what I want to mention here is that unless you go deep and see, you will not know what is there below. And our job is to find out what is there below. So site investigation is very, very important. And you do that with, tests in field. You do that by collecting samples and doing the test in the laboratory. And all these are important. So what do you do here? You do several determination of several parameters like, soil basic properties, index properties, the level of the groundwater table, strength parameters, settlement parameters. Use them to classify the soil, decide the depth of foundation, find SBC of soil, even suggest some ground improvement technique if required, or maybe you can even suggest the type of foundation. And if this is the foundation, this is the base of the foundation, you are interested in the soil properties below the base of the foundation for a depth equal to 1.5 to 2 times the width of foundation. So this is what is important, because this soil is the one which takes the load. Okay. Depth of foundation, as I earlier said, is the level till the bottom of the foundation. And lot of these factors influence the depth of foundation. I can actually spend hours talking about each of them. So you go to that depth at which bearing capacity is adequate. Go to that depth where there is no seasonal moisture changes, especially in case of BC soil. In cold countries, you go to that depth where there is no effect of freeze-thaw condition. Near the surface, there will be effect of freeze-thaw conditions, depending on the temperature. But you go deeper, that effect reduces. You go to that depth. Similarly, in a area where it is waterlogged or where there is a river, you go to that depth where there is no effect of scour. And IS says, minimum depth required is 500 millimeters. And you go to that depth where the tree roots do not pose problems. Burrow animals like snake, ant, mouse, they don't cause problem. Sloping ground, you have to be careful. When you have adjacent structures, you have to be careful. If there is some underground defect, maybe caused due to mining subsidence, you have to be careful. So if you have a sloping ground, the edge of the footing, it should be having some minimum, distance from the edge of the slope. For rocks, 600 mm. For soil, 900 mm. And then, when you plot this slope should not be steeper than 2:1. And then, when you have two neighboring footings, the spacing between them should be large. If the spacing is not large, there is every possibility of overlap. You're not supposed to put a footing, something like this, with overlap. In that case, you need to go in for a combined footing. So if, let us say, the spacing, you have to think of, it should be large. How large? IS says X should be minimum, equal to maximum of one of the foundations. B2 is the width of the other foundation. B1 may be the width of the existing foundation. B2 may be the width of the new foundation. So X should be, the spacing should. If not, you have to go in for the combined footing. Then there is a mention on loads also. Loads can be vertical or horizontal along with moments. Normally, you consider dead load and live load, one case, or dead load, live load, plus either wind or earthquake load. And when the quantity of the magnitude of wind or earthquake load is less, you neglect that. So whenever the wind or earthquake load is less than 25% of dead or live load, you neglect their effect. If not, you consider their effect. When you consider their effect, you need to increase the SBC by 25%. So you have got SBCS 200 kilonewton per meter square. If you are taking the wind effect and or earthquake effect, instead of 200, you take it as 250 kilonewton per meter square. So these are the mentioned factors of safety for sliding stability here. When you consider both earthquake load and wind load, in addition to dead load, live load, and earth pressure, it should be 1.5 or more. And when you consider without the wind load and earthquake load, it should be 1.75 or more. And in general, in a soil which has low friction, you should always think of anchoring it well. And stability against overturning, 1.5 or more when you consider dead load, live load, earth pressure, along with wind and earth or earthquake load. Or 2. And settlement, 2 important types: uniform settlement, differential settlement. This settlement happens because the soil, like compressible soil, experiences downward movement, and hence the structure also moves down. If the structure moves down uniformly, it is uniform settlement. If one portion of the structure moves more compared to the other, it is differential settlement. So this is S max when it is uniform. S max is same at both places. Otherwise, S max and S min. So maximum settlement is simply S max. Differential settlement is S max minus S min. And we also use this angular distortion, that is S max minus S min over whatever length. If this is the length L, by L. So this is what is the table 1, which gives the values. Please note that number 1, this is for isolated footing. 2, this is for raft foundations. 2 extreme types of soils. Isolated footing, one is sandy soil or stiff clay, and another one is plastic clay. Similarly, raft foundation, sandy soil or stiff clay, and another one is plastic clay. Different types of structures: steel structure, RCC structure, and multi-story structure with RC structure or steel structure, in which you have the panel walls or you have load-bearing wall. You also have water retaining structures, water towers and silos. For all these, the permissible values are given. So maximum settlement in millimeter, you can see here 50 like this. Differential settlement is given in terms of this 0.0033 L. If L is 10 meters, this is 0.033 meter or 33 millimeter. So whatever I said, S max minus S min should be less than 33 millimeter. Or it can be given in terms of angular distortion, 1 over 3000. So what I said, S max minus S, whatever value is there, divided by L should be equal to this 1 over 3. So these are given. I just mentioned here also, same thing I have repeated. Say for raft foundation, isolated footing, sand and stiff clay, plastic soil. Similarly, for raft foundation also given, both for steel and RCC structures I have mentioned here. Lastly, I go to IS 2131. IS 2131 talks about standard penetration test. So standard penetration test is a field test. Very, convenient test. But unfortunately, in India in particular, it is abused. We simply find SPTN value, which is not standard. So each one of us have our own method of doing things in spite of, the regulations. So strictly we need to follow IS 2131. And today we have more automated ones. We have to be careful. So what do you do here? You simply try to find the penetration resistance of the ground at any depth. For that you have a split spoon sampler, and that is penetrated into the ground, for which you apply a loading energy. You apply the load through a standard hammer of 65 kgs, dropped from a height of about 750 millimeters, and find out how many blows are required for this by 30 centimeters or 300 millimeters beyond the seating drive. So initially 150 millimeters, we call it as seating drive. We allow that 150 millimeters. We don't need to record the number of blows required. Beyond that 150 millimeters, how many number of blows are required to penetrate by 300 millimeters is recorded as observed N value, observed SPTN. So it's a mere integer. In very soft soil, sometimes N can be 0. You don't need to apply any hammer load. Automatically it penetrates, soft soil. Okay. So you require a split spoon sampler, hammer, tripod, drill rod, pulley, and some lifting devices, and anvil or the head, for dropping the height. Okay. And dropping the hammer. So these are all the components of split spoon, SPT and SPT test, standard penetration test. This is the split spoon sampler. So you can split it into two parts. So you penetrate this into the ground, and when you penetrate, the soil gets collected here. You can actually take the soil. It can be used to some extent as undisturbed portion also. It has a diameter of 38 millimeter, therefore it can directly be used in triaxial or unconfined compression test. So we should carefully take out the soil. In addition, you would have found out SPTN value. So the procedure I have mentioned here, I'm going to skip this procedure here. Okay. The advantage of SPT test is that, you don't require anything directly in the field. You do the test, and today you can do it mostly automated, and you can go to great depths also, 5, 10, 20 meters and so on. The spacing, vertical spacing at about 0.5 to 0.75 meter, you can get the readings. In addition, at those depths, you can collect soil samples also. So you can actually do certain other tests in the laboratory on those samples and see whether there is consistency between what you have found in the field and laboratory. And this SPT is the observed N value. This needs corrections. One of the most important correction is, energy correction, but IS 2131 is silent on that. It is going to talk about only 2 corrections. Okay. Anyway, when you do this SPT and SPT standard penetration test, you have to mention the origin of sample, job designation, the boring number, sample number, depth of sampling, penetration record, length of recovery, date of sampling, and so on. The 2 corrections mentioned are dilatancy correction. This is applicable in saturated fine silty sand. If the fine silty sand is in, say, it is very dense, then interestingly, observed N value will be much more than the actual value. That is because the water present in the voids, so that will have that negative pressure, and hence a correction like this is applied. On the other hand, if it is in loose state, under the dynamic load, there is a possibility of nearly liquefaction kind of thing happening, wherein, excess pore water pressure is developed. And because of the presence of excess pore water pressure, the correct actual, strength will be much more than observed strength. So this correction has to be applied. And the other correction is the overburden correction. So in geotechnical engineering, overburden plays an important role. Soil at the surface will behave very differently from a soil at some depth below. At some depth below, soil is confined in all directions. Therefore, it's much more stiffer. So overburden pressure is applied, correction is applied like this. This table is available. So you need to find out what is the pressure, overburden pressure at the depth considered. If let us say depth considered is 10 meters, the average unit weight of soil is 20 kilonewton per meter cube. Then overburden pressure is 200 kilonewton per meter squared or 2 kg per centimeter squared. So for this 2 kg per centimeter squared, you find out the correction required. So correction if it is 0.78. If n is 30, you don't apply n equal to 30, but corrected n is equal to 30 into 0.78, lower. On the other hand, if near the surface, so it is not confined, therefore it is going to show less resistance, then the value of n correction which you need to apply will be much more than 1. So this is the overburden correction. With again concluding or stressing that soil is a complex construction material. I always try to say that it is a smart material, intelligent material. So if you abuse, it naturally gets angry. It shows its anger in the form of a failure. And then properties of soil vary enormously from place to place, time to time, and so on. Therefore, you have to be extremely careful in handling the soil. And water always is the major culprit in geotechnical engineering. If there were to be no water in soil, you wouldn't have had geotechnical engineering at all. Every soil would have been good enough to hold any structure. But that is the one which poses challenge, and we have to treat it with care. So with this, I just would like to mention that today I covered 3 IS codes. The first one was IS 6403, according to which bearing capacity equation can be determined for the soil, and hence you find SBC of soil, okay, considering several factors like the groundwater table, eccentric loading, depth of foundation, inclination of load, shape of the foundation, mode of failure, and so on, both for cohesive as well as cohesionless soil. And then I talked about IS 1904, wherein the permissible foundation settlement is given in addition to the factors considering the depth of foundation. Lastly, briefly, I discussed about SPT, standard penetration test, the test procedure, and then the 2 corrections: correction for dilatancy and correction for overburden pressure, as given in IS 2131. Today, geotechnical engineering is there to stay. It has grown enormously, and it still has a lot of growth possible. We have a lot of activities happening above the ground. I'm sure we'll have more and more activities happening below the ground. I'll not be surprised tomorrow if we have a city built below the ground. You have activities like foundations, tunnels, soil exploration, retaining walls. So geotechnical engineering is very much valuable for the infrastructure of tomorrow. With this, I close my discussion. I'll have to thank all of you for having patiently listened to me. More than that, I'll have to thank my colleagues in the Department of Civil Engineering at Vidyavardhaka College of Engineering for providing me this opportunity and for really working along with me for whatever I say. And my sincere thanks also to Association of Consulting Civil Engineers, Mysore Center, because they have always been supportive of us. They said that for all activities which VBC undertakes, we are there to support. My sincere thanks to all, and good luck to all the participants for doing your quiz, and I want you people to do in more numbers. Thank you very much.
Thank you, sir. We will go ahead, and we have one question asked from the participant. Which bearing capacity theory is best, and what are the differences between Merov-Sanson's and VBC's IS code methods?
Well, I don't say any of these bearing capacity theories as, one better than the other. Because basically, finally, you have these factor of safety, huge number 3, which we take. So normally, any of the general theories, other than Terzaghis theory, do take into account the effects of depth, weight, and depth, shape, and several things. So any one of them should be okay. And I have no problem with this IS code method, IS 6403.
Okay, sir. Thank you, sir. Thank you, sir. That's the only question asked. Thank you, sir. There is a small announcement to the participants. Due to some technical issue, there is a problem in sending first day certificate. We will send it soon. I request the participant to kindly bear with us. Now I request Professor Arjun V to deliver a vote of thanks.
Good afternoon, one and all. It's my privilege to propose a vote of thanks on day 3 of a 6-day webinar series and e-quiz on BIS codes, organized by Department of Civil Engineering, Vidyavardhaka College of Engineering, Mysuru, in association with Association of Consulting Civil Engineer, India, Mysore Center. Firstly, I would like to thank today's speaker, Dr. S.K. Prasad sir, for enlightening us on various codal provisions related to geotechnical engineering, namely IS 1904, 2131, 6403, and enriching our knowledge on safe bearing capacity, design and construction of foundation, standard penetration test. I thank you, sir.
Thank you very much.
Civil Engineering Department, VBCE, Mysuru, is providing an opportunity for the participants to understand the BIS code used in the civil engineering effectively, and the participants are using this opportunity by participating in very good numbers. There are over 1,500 registration for this program. I take this opportunity to thank all the participants for attending this webinar in large numbers and attempting e-quiz. I request you all to continue to attend this webinar series for the entire week. I take this opportunity to place a record my hearty thanks to the management of Vidyavardhaka College of Engineering for all the supports they have provided in organizing the 6-day webinar cum e-quiz. I thank our beloved principal, Dr. B. Sadashivegowda, for his continuous motivation and encouragement in organizing this program. My heartfelt thanks and up to Engineer S. Prakash, Chairman, Engineer M.S. Ram Prasad sir, Honorary Secretary, and all the members of Association of Consulting Civil Engineers India, Mysore Center, for their support and gesture of sponsoring this event. Thank you. I express my thanks to the Vidyavardhaka College of Engineering in general, civil engineering in general, and civil engineering department in particular. We eagerly await your submission of e-quiz answers on Google form by 3 p.m. today. And see you all tomorrow morning at 11 a.m. for next webinar on IS 800-2007 by Professor Rajit TJ. Thank you, one and all.
Good.
Thank you, Arjun sir. Thank you, everyone. We appreciate you being here. Thanks again for joining us today. And we look forward for your presence for our next webinar tomorrow on BIS Codes for Steel Structures, IS 800-2007 by Professor Rajit TJ. Thank you.